Hello learners, this is Education Online program. Our subject is chemistry and the topic is percentage purity. What is it, percentage purity? If we are talking of percentage, it means we need to know something out of 100 of that pure substance that we obtain. So it means if you are in the lab, then you need to get a pure substance that you wanted, or the exact material that you wanted by percentage. So we can say that a percentage purity is the percentage of the material which is the actual desired chemical in amount of substance or product. So we need to get the exact desired quantity of what we wanted from the substance or the product. So we need to get the exact what? Desired product. So here when we talk of percentage purity is percentage purity is the percentage purity is the percentage of what? Percentage of the materials percentage of the materials which what? The percentage of the material of the exact desired substance that we wanted. So here we can say that the percentage purity is the percentage of the material of the exact desired substance or product. So here we can say that exact material of the desired amount of what? Amount of the product or the substance that we needed, of substance or product. So it means if you are in a laboratory and you want to get a substance or a product which is pure, so you need to know the percentage of that purity. So you need to know the percentage of that purity. That is why we call it as the percentage purity. It means you have something in your mind that you wanted to get. It means, for example, you want to get calcium oxide and you want to know the purity or the percentage purity of calcium oxide. So in this case, calcium oxide is the product that you need. So how do we usually calculate for this percentage purity? So we have a formula for us to get or to calculate the percentage purity of the product that we wanted. So what is this, first of all, this percentage purity used for? So here we can say that percentage purity is usually used for the extraction of table salt, can be for extraction of crude oil. Also we can say that it's used in extraction and purification of what? Of metals. So the uses of percentage purity, first of all, it is used in extraction of table salt, and also it is used for what? It is also used for the extraction of crude oil. So here extra percentage purity is most usually used in what? In the in companies or industries whereby there is a crude oil production and also extraction of the table salt. Also it can be used for what? For the extraction. It is also used for extraction and what? Extraction and purification. Extraction and purification of what? So we can say that it is for extraction and purification of metals. So there are metals which are very important in our daily life, and we can use percentage purity for us to get the percent of the pure metal that we wanted. Also, it can be used for getting the percentage of table salt when we extract table salt, and also in crude oil production. So here we say that here we can say that the formula for getting the percentage purity is the percentage purity of a salt. So here the percentage purity of a salt will be equals to the mass of pure salt equals mass of pure salt divided by the mass of what? Of impure salt. So this will be multiplied by 100. So we shall say mass of impure salt. So here mass of impure salt, and there we have above is the mass of pure salt, and then below is the mass of impure salt. Then we multiply it by 100. So here this will give us the percentage of the pure salt that we wanted. So in this case we need to remember that here when we are dealing with the percentage purity of a salt, we need to get it by the formula which says that is the percentage purity of a salt will be equal to the mass of the pure salt divided by the mass of the impure salt. Then we divide by 100. So here in this case we can have an example at least to clarify how we use this formula for getting the percentage purity. So we shall say here we have an example that say that example, we have 30 grams of what? 30 grams of impure calcium carbonate, 30 grams of impure calcium carbonate, impure calcium carbonate, it means here that impure calcium carbonate has what? 30 grams. So here we shall say that the calcium carbonate, the common name is the chalk we usually use for the BB or the blackboard. So we shall say that was reacted with an excess what? Excess dilute what? Dilute hydrochloric acid to produce 2240 decimeter cube of carbon dioxide gas at STP. So here remember that STP here is the standard temperature and pressure of the gas here. So the gas here is carbon dioxide and the volume is 2240. So we need to remember that the standard temperature and pressure here will give us a volume which we shall see as 22.4 decimeter cube. At standard temperature and pressure, we have the volume of the gas, or the ideal gas, is 22.4 decimeter cube. So this, you are asked to calculate what? Calculate the percentage of pure calcium carbonate. Percentage of pure calcium carbonate. So here at the molar gas volume will be equals to, at STP, will be equals to 22.4 decimeter cube. So given that, we need to remember the relative atomic mass of calcium, relative atomic mass of carbon, the relative atomic mass of oxygen. So those ones now we are familiar with it, and we are going to calculate it direct from our mind. So in this case, we have to remember that we are going to use the formula above, which says that the percentage of pure salt will be equals to the mass of pure salt divided by the mass of impure salt, then we multiply by 1000. So we have to go ahead and we need to calculate the items that are required. So here the formula is, so we need to go to the solution for the formula, for the problem given. We need to remember that 30 grams of calcium carbonate, which is in pure form, was reacted with an excess dilute hydrochloric acid. So the amount of hydrochloric acid is not known here. So we need to, that produces 2240 decimeter cube of carbon dioxide gas at STP. So it means here we have to remember that calcium carbonate, which is in pure, produces carbon dioxide with that amount of 2240 decimeter cube at STP. So here the standard temperature and pressure, the molar gas volume will be equals to 22.4 decimeter cube. So we have to first of all calculate the number of moles of calcium carbonate, and we proceed from the equation. So the chemical equation here will be calcium carbonate plus hydrochloric acid will be giving us calcium chloride plus carbon dioxide plus water. So here we have liquid, we have gas, and we have this as solid. So this is the chemical equation representing the reaction that has taken place in this experiment. So we have calcium carbonate plus hydrochloric acid will give us calcium chloride plus carbon dioxide and water. So here this one is in form of aqueous solutions. So here we have solid is the calcium carbonate, which is a chalk, and hydrochloric acid is aqueous solution. So we have to remember that by putting all those subscribe below, it shows that this the products that are going to be given out are carbon dioxide, and we have water as a byproduct, and also calcium chloride is one of the products. So what is important here is the calcium carbonate and then the carbon dioxide. So here we'll have to balance the equation by putting 2 as the 2 moles of hydrochloric acid reacted with the 1 mole of calcium carbonate. So here we shall say, first of all, the step 1. In step 1, we need to find what? Find the molar mass. We need to find the molar mass. Molar mass of what? The molar mass of calcium carbonate. So here, getting the molar mass of calcium carbonate, we shall say that calcium carbonate is made up of 3 atoms: calcium, carbon, and oxygen. So we have calcium is 40, or the relative atomic mass is 40, plus 12 of carbon plus oxygen. Here we have 3 atoms of oxygen. So we shall say 16 multiplied by 3. So when we calculate this out, we shall say that the relative formula mass of calcium carbonate to give us the molar mass will be equals to 100 grams per mole. So this is the molar mass of calcium carbonate, which is the solid in this reaction. So we shall have to go ahead and we go to step 2. So here in step 2, what are we going to do? We are going to calculate the moles of what? Of carbon dioxide produced. Moles of carbon dioxide produced in this reaction. So we need to remember that the volume given is 2240, and at STP we have the molar gas volume is 22.4. So we shall say that this 22.4 decimeter cube is in decimeter cube, but here also we have to remember that this one, or the volume given here, is in centimeter cube. So this centimeter cube and this one decimeter cube, it means we need to change one of the units at least to be uniform. So we shall say that the 22.4 we have to change it into centimeter cube. It means we have to multiply by 1000. So we shall say mass, we shall say that moles of carbon dioxide will be equals to the volume given divided by the molar gas volume. So remember that moles of carbon dioxide, or 1 mole of carbon dioxide, will be equals to the volume given divided by the molar gas volume. So the molar gas volume is 22.4. When we multiply by 1000, will be 22,400 centimeter cube. So this will be the molar gas volume. So we need to put it into the formula here, and so that we calculate out what is the moles of carbon dioxide. So we shall say 2000, which is the volume given is 2240 centimeter cube, divided by, when we multiply 22.4, will give us 22,400 centimeter cube. So this and this one will go away, and we shall have to divide this 2240 divided by 22,400 will give us 0.1 moles of carbon dioxide. So the moles of carbon dioxide here is 0.1 mole. So the mole here, we have to remember that is 0.1 mole of carbon dioxide that reacted or that has been produced from the reaction of calcium carbonate with what? With the excess hydrochloric acid. So we need to go ahead and so that we get the pure substance in this reaction. So we shall go ahead and continue from there. So we need to remember that moles of calcium carbonate is the same as moles or is equals to moles of carbon dioxide, which is 0.1 moles given. So here the moles given here is the same as the moles of carbon dioxide. Why do we say so? Because we have 1 mole of calcium carbonate produces 1 mole of carbon dioxide. So also we have to go ahead by getting the mass of calcium carbonate that reacted. So the mass of calcium carbonate that reacted will be equals to the moles will be equals to moles multiplied by, or the number of moles multiplied by the molar mass. So the molar mass here is 100 and the number of moles is 0.1. So when we multiply 0.1 by 100 here is the molar mass of calcium carbonate. So we shall say that 0.1 when you multiply by 100 will give us 10 grams. So here 10 grams is the mass of calcium carbonate that reacted to give us calcium chloride, carbon dioxide, which is the main product that we need, and water. So we shall say, continue that. Remember, 22.4 liters of gas is produced by 100 grams, which is 1 mole of calcium carbonate. Only 10 grams of, so remembering from the equation there, that's 22.4 decimeter cube, which is the same as liters of gas produce 100 grams, which is the molar mass of calcium carbonate, which is 1 mole of calcium carbonate. Only from this we have from this 100 grams we have only 10 grams of calcium carbonate. 10 grams of calcium carbonate reacted in this reaction, reacted out of 30 grams. So the impure calcium carbonate was 30 grams, and so the one we got from the theoretical expression here is 10 grams. So for us to get the percentage of the pure salt here, we shall say that we are going to divide 10 by 30 and we multiply by 100. So from the formula, as we saw before, we shall say that percentage purity will be equals to of calcium carbonate. Let me put clearly, at least so that you know what is this percentage purity of the pure substance. The percentage purity of calcium carbonate in this form will be equals to 10 divided by 30 and we multiply by 1000. So when we divide 30 by 1000 by 300 by 30 and we multiply by 100. When we divide 10 grams, divide by 30, we multiply by 100, will give us 33.33 percentage. So it means the percentage of pure calcium carbonate used in this experiment is 33.33% of percentage purity. So this is how we get the percentage purity of the substance that we needed. So in this case, we have to remember that percentage purity, as we said before, is the amount of the exact or the percentage of the amount or the materials of the desired materials of the product that we need. It means the product here in an experiment whereby you need to get a pure salt, so we need to get the percentage of the pure substance that reacted, and we calculate it through the formula which says that percentage purity is equals to the mass of the pure salt divided by the mass of the impure salt, and we multiply by 1000. So in this case we get what? We get the percentage purity. So as we said before, that the percentage purity is very important in the extraction of the table salt and also in crude oil refinery. Also it is very important in extraction and purification of what? Of metal. So we need to remember that percentage purity is very important in our usual, in our daily life. For example, the simplest example is the table salt that we use in our various homes. So with this example, we have come to the end of this lesson. So thank you very much for listening, teacher Lily.